see I have the station. So do I know what L is? What is it? Remember, L represents the horizontal distance, right?
L is 7, 8, I mean 6, I can't do math right now.
It's
G1
Six.
minus.
No, just L.
it's the station final minus station initial.
It's 49 plus 70 minus 43 plus 70, which is 600 feet or
60.
6 stations. Right?
Mhm.
L is the horizontal distance. Remember, the stations are horizontal. So the BBC is at 4370, and then it goes to 4970. So the distance here is 600 feet, or 6 stations. If I am given the elevation of the VPI, NG1 and G2, can I figure out the elevation of the BBC?
Yes.
Yes. So what do we know? It's grade, right? We know percent grade is equal to change in Y, change in V, over change in H times 100, right? We know that already. So that means this is 0.03 is equal to the change in V, which I'm solving for. And what's the change in H between these two? Equal tangent curve.
It's half of 300, 3
300
stations.
feet. So 300 times that turns out to be change in V is equal to 9, is that right? 9, so if the elevation of the VPI is equal to 853.48, what is the elevation of the beginning of vertical curve going to be? 853.48, what? Minus 9 feet, which turns out to be 4, 4, 5.
Why are we changing that percent into decimal?
Because now I'm just doing
Different?
math, I'm not doing
Oh.
surveying.
I was confused.
No, very good point. But I'm just doing math. When we did percent grade, we used it as math, we didn't think about it.
Yeah.
I mean, we could do it different, but then what would be the same thing? So this is the math way of doing it.
Yeah.
Here's the surveying way of doing it. It would be, percent grade would be 3 is equal to the change in V over 3. So change in V would equal to 9. So it comes out to be the same. So what about this? What's the elevation of the EVC? I'm going to do it graphically now, right? Rather than kind of do it, I'm going to do it like this instead. I'm just going to show the picture. So the H is another 300 feet, and the change in V, and I know this is negative 2.4%, right? So percent grade, same kind of thing, is equal to change in V over change in H times 100. Negative 0.024 is equal to the change in V over 300. And change in V turns out to be 72 maybe? 7.2
Yeah.
feet? Yeah. So the elevation of the EVC is going to be equal to 853.48 minus 7.2. $846.28.
Yeah.
Is everybody following me? So what we just did is what we did from day 2 of class. We calculated the slope. We were given the elevation of the higher point, we needed the elevation of the lower point, we knew the horizontal distance between them, and we knew the slope. So now, we just calculated these two numbers. so we know they're right. Is there a way we can check this number?
Yes.
How? How can we calculate the elevation of the EVC?
We know that.
That long equation.
Yeah.
The elevation, the elevation of the EVC is equal to the elevation of the VVC. Could you read it? Plus G1,
G1 X
which would be L,
L
right?
plus R over 2.
R over 2 times L squared, right? So we have to calculate what R is. So the equation for R was G2 minus G1 over L, right?
Yeah.
Now we think like surveyors. Negative 2.4 minus 3 over 6 equals, what's this number? Minus 5.4 over 6, and what does that turn out to be? 0.9? Somebody do the math?
Yeah.
5.4, what is it?
0.9, you got it.
0.9.
The even?
Yeah.
Yep.
Oh, great. Nice. So the elevation of the EVC is 844.48 plus G1 is 3 times 6 plus R is negative 0.9 over 2 times L, which is 6 squared. So somebody do that. And see if you get 846.28.
I got 846.28.
Great,
I concur.
okay, good.
I just knew what I had.
Okay, so now,
Mm-mm.
oh, yeah. Okay, these guys, Cody K. Okay, Ivan, Seth, Z, you are all solving for the elevation of 44 plus 0, 0. So what's going on is we have a BBC of 43 plus 70, we have an EVC of 49.70, but we always like we always like to deal with full stations. So you guys, your line is going to solve for the elevation of 44 plus 0, 0. Okay? Nathan and Melissa, you're going to solve for the elevation of 45 plus 0, 0. Okay?